Okay, so in section 5.3, we briefly introduced you to synthetic division. And so now we're going to practice more of that synthetic division. And so every time you see the word long division, you can get rid of that word because we're only going to be practicing the synthetic variety, okay? So we need to keep the practice going, and we know that we need to take the 0. See, another way to write this instead of horizontally would be something divided by x minus 2. So when you are not given a 0, like yesterday, the 5.3 lesson, I gave you a 0. Okay, and I said, this is a 0 of the polynomial. Well, in this particular case, you need to be able to take the factor, or the part that you're dividing by, and I use that term factor loosely, maybe I should put it in quotes, because I'm not sure if we're going to get a 0 remainder or not. We might not get a 0 remainder. If we do get a 0 remainder, that means x minus 2 goes in evenly. If we don't, then I'm going to show you how to deal with remainders. So, the 0 that we get from x minus 2, remember we set the factor equal to 0 and solve, we get is 2. So in the box, on my synthetic division, I'm going to put a 2. My individual coefficients are 3, negative 4, and 3. 3, negative 4, and 3. There's no missing terms, so I don't have to put a 0 in for anything. Remember how we separated off the last column and left space for our row. Always, always, always carry that one down below the line. And then we go through that process of multiplying and adding. Multiplying. Now, in this particular case, look, we got a remainder of 7. We didn't get a 0. So x minus 2 does not go in evenly. But I need to be able to interpret what I see. If that is the remainder, this must be the constant, and this must be the linear. So I have 3x plus 2. Now how do we write remainders? Okay, I'd like to take a trip down memory lane, down back to middle school. Now maybe when you were in elementary school, they might have done a question like this and said something like 7 goes into 13 one time with a remainder of 6. Now, back in elementary school, they might have let you get away with writing R6 for remainder. But then when you got to middle school, they wrote it differently, didn't they? They said 1 with 6 left over. And they said that by doing this. 1 and 6/7. Now the one thing that they didn't show you is that there is a plus sign in between those. We never write that. We say something like 1 and 6/7. But that's really a plus sign because you're adding those two things together. So how do I interpret that for this remainder? Well, notice when you wrote your remainder, right? Here was your remainder. There were 6 left over. Where did this number come from? It came from what you were dividing the whole thing by. Okay, so the 7, what are we dividing it by? Oh, the x minus 2. So that's the answer to the question. The quotient is 3x plus 2 with the remainder of 7. Now, I'll show you if we run into that, a different type of problem, how I write it. So once again, all synthetic division, right? No long division. So what's the 0 that you get from x minus 1? Well, it's positive 1. Your coefficients are 1, 3, 1, 6. 1, 3, 1, 6. And we separate off that last one. Carry down the 1. Multiply. Add. Multiply. Add. Multiply. Add. So what did we get? Well, of course our remainder is 11. That's the part that's over x minus 1. Right, so that's my answer, 11 over x minus 1 in that part. But then what's next to that? We got our constant term. We got our linear term. And we have our quadratic term. That right there is the answer to question 2, using synthetic division. If you need to pause the video at any time just to kind of copy things down, do so. We're going to keep moving forward. Okay, so what's the 0 that we get from this? We get a 2. You know what? I should move it over farther. Oops, not that. That doesn't help anybody. My zeros are, or my coefficients are 4, negative 5, 2. 4, negative 5, 2. Carry down the 4. Multiply 8. Add 3. Multiply 6. Add 8. So the 8 is over the x minus 2, because that's what you're dividing by. So that's going to fill this space. What do we have right there? Well, we have a constant of 3 and a linear term of 4x. Determine whether the given binomial is a factor. Okay, so just in the spirit of practicing more synthetic division, we've got coefficients of 1, 11, 15, and negative 5. And in the little box up there, what's the 0 that you get from x plus 2? That would be negative 2. Right, remember how you set it equal to 0 and solve? I know, I sound like a broken record. Carry down the 1. Multiply, add. Multiply, add. Multiply, add. What are we interested in? We are interested in the remainder. In this particular question, I don't care about writing out the quotient with the remainder. I care about the remainder, okay? In order to be a factor, the remainder must equal 0. Does it? Answer, no. Remainder has to equal 0 for something to go in evenly, and clearly this does not go in evenly. Okay, same idea. So the 0 that we get from x plus 5 is negative 5. We have coefficients of 1, 7, 7, negative 15. Carry down the 1. Multiply. Add. Repeat. Multiply. Add. Multiply. Add. Ding, 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 ding. We got a remainder of 0. What does that mean? The answer is a yes. Because the remainder is equal to 0. That must mean that x plus 5 goes in evenly. So we're doing more practice with synthetic division here, just because you guys got to get the hang of it. We've got a 6 that goes in the box. Coefficients are 1, 9, negative 3, 2. Once again, I didn't leave myself enough room. 1, multiply, add. Multiply 6 times 15. What is that, 90? Did I do that right? 1, 9, negative 3, 2. Okay. 6. Okay. Add them together, get 87. 6 times 87. Ooh. I know it's over 480. 522. Add and get 524. So we have a, see, this is where I wished I would have scooted my work over so that you could see my remainder easier. 524 over x minus 6. That's my remainder. What's the other part? Well, it's got an 87. It's got a 15x. And a positive x squared. Now, question 7 kind of goes along with some of the stuff we were doing in the last section. Use synthetic division and the given factor to completely factor this. Now, if you'll notice in question 7, they have given you a hint. They're telling you that x plus 5 is a factor. So when we get done, we'll have 3 total factors. What should I put in here in the box from the x plus 5? Answer, negative 5, right? So our coefficients are 1, 6, 3, negative 10. Drop down the 1. You know, you can always practice by pausing these, seeing, do it, and see if then play the video and see if I match what you got. That'd be smart. Negative 5 just for the practice. Adding, get 1. Multiply, get negative 5. Add, negative 2. Multiply, positive 10. Hey, we got a 0. So what does this give me? It gives me a negative 2. It gives me a positive x and a positive x squared. Question is, can you factor x squared plus x minus 2? And if so, what are you going to factor it into? Well, x and x, right? Factors of negative 2, well, that means one has to be positive and one has to be negative. But when you do the insides and the outsides, you end up with a positive 1x. So must be those values right there. Well, there it is. We factored it. So we use the synthetic division to get it from a cubic to a quadratic so that we could factor it the rest of the way. Okay, question 8 is something called the remainder theorem. There's this cool theorem that says if you just want the remainder, take the 0. Okay, so this would be the 0 that you're given, and plug it in for every single x. And what you're going to get is the remainder. Now, why is that so interesting? Because if the remainder equals 0, then we know that it's a 0 of the function. Now we call it a 0, but I guess we kind of assumed that we would get 0 as a remainder, so that may be a little bit, we might be wrong on that. So 3 cubed, that's 27. 3 squared is 9, and 9 times 4 is 36. Negative 3 times 3 is negative 9 plus 5. So 27 plus, let's see, 27 plus 30 is 57, and then 6 more is 63. 63, take away 9. 63 take away 9 is what? 54. And 54 plus 5 is 59. So 59 is the answer. Now, they might ask me, does that mean that this is truly a 0 of the function? And the answer is no. So I was making an assumption because it's not a, I guess I should say x minus 3 is not a factor, right? When it's got a remainder of 59. Use the remainder theorem. Sorry for yawning. I apologize. Use the synthetic division. We already know how to use synthetic division, so let's just practice with the remainder theorem. We're going to take this 1/2, and we're going to plug it in for all the x's. So 2 times 1/2 cubed minus 1/2 squared plus 8 times 1/2 plus 5. All right, let's see here. 1/2 to the 3rd power. That would be 1 times 1 times 1 over 2 times 2 times 2. That's 8. All right, and then we're going to multiply that times 2. Minus, okay, so that's 1/2 times 1/2. That would be 1/4, which would be 1 times 1 on the top and 2 times 2 on the bottom. And then, of course, we have 8 times 1/2. That's 4. At the very end, we have a 5. Well, 2 times an 8th, that is 1/4, right? 2 over 8 is 1/4. And if we're going to subtract a quarter, well, those will cancel out, and so we just get 5 plus 4, or 9. Does that mean that 1/2 is a 0 of the function? It definitely is a big fat no. Nope, not at all. In our day and age, instead of using the phrase big fat no, can we say big thick no? Is that right? Wrong? I hope I'm not swearing. Okay. Is the binomial x plus 4 a factor of that? That means remainder 0. Remainder 0 would be a yes. Anything else would be a no. So, what's the 0 that you get from this? -4, right? So, I can take -4 and raise it to the 3rd power, plus 13 times -4 squared, plus 32 times -4 minus 15. You guys are yawning so much that it's causing me to yawn, okay? And I just don't appreciate it. Okay, -64. Let's see, 16 times 13. 16 times 13. 208. Okay. 32 times -4. Well, that's a -128. And a minus 15. So -64 plus 208 minus 128 minus 15. Ooh, got a positive 1. Did I type that right? -64 plus 208 minus 128. All that for a remainder of 1. The answer is no. use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. Okay, so factor theorem, okay, we're going to do synthetic division. We could do remainder theorem or synthetic division, right? So we could use this -5 and we could go through. There'll be specific questions that ask you for the remainder, but we could do this. We could do 1, 6, 3, -10. Multiply, carry down the 1, right? Multiply, add. Multiply, add. Multiply, add. Is the answer yes or no? Well, we got a remainder of 0, so the answer is yes. Same thing would happen if I took -5 and I raised it to the third, plus 6 times -5 squared, plus 3 times -5 minus 10. I would end up with 0 because those two things have to match. Now, I want to show you one other question from section 5.3 that we didn't get to yesterday. So I'm going to flip back to 5.3, and I want to go to 5.3, question 12. 5.3, question 12. Okay, so let me flip back here quickly and find question 12. Okay, so in this particular question, what I'd like to do is I'd like to move this to the other side. So that's x to the 4th minus 26x squared plus 25 equals 0. Okay, now, we talked about briefly in class, how do you know how many zeros there are? It's a 4th degree polynomial. The most it could be is 4. In fact, I'll try to be nice to you and just stick to the degree so that we don't end up with some ugly numbers. And I would need to give you 2 hints on this question. You're like, oh, yeah, 2 hints? Come on, stop that. Okay, well, stop moving that around too. So we would give you 2 hints. Hint 5 and 1 are zeros. Okay, so that's weird. We've never had one where it gave us 2 of the zeros. So I want to show you, yes, we're going to do synthetic division. There's something tricky about this one, though. So we're going to start with 5. Come on, don't be moving on me. But we got to be careful. My coefficients are 1, 0, -26, 0, and 25. Now you're saying, Mr. Staley, where are those extra zeros coming from? Well, you notice that over here there's no cubic term and no linear term? That's why they're missing. We would have to include zeros. Okay? I might make this an extra credit question. We'll see. So, bring down the 1. So, go through the same process. 5 times 1 is 5. Then I add down the columns. 5 times 5 is 25. Then I add down the columns. 5 times -1 is -5. Add down the column. 5 times -5 is -25. Add down the column. 0. Well, I knew it was going to give me 0. But this time they gave me a second one. Not only did they give me 5, but then they gave me 1. So guess what I'm going to do? I'm going to keep going with my synthetic division instead of, some kids think you're supposed to go back to the beginning. No, we just keep going. So 1, carry down the 1, then we multiply, add. Multiply, add. Multiply, add. Got a 0 again. What am I left with? I'm left with x squared plus 6x plus 5. Remember, go from left to right, so constant, linear, quadratic. Can you factor that further? I hope you can. Now, in this particular, so that would be x plus 5 and x plus 1, right? Factors of 1, or factors of 5, so that'd be 5 and 1, and they add up to 6. So, how many solutions are there to this question? Well, you better tell me the original ones, 5 and 1. But what are my other two solutions? Negative 5 and negative 1. 4 different answers. But if you're given 2 hints, you just keep going with your synthetic division. First you use hint number 1, then you use hint number 2, and you get it down to a quadratic, and then you can factor the rest of it. Yes, we'll need to practice in class. Have a wonderful day flexing. Try not to tear any muscles while you are flexing.